Hi, I'm Phil, and today we're going to start our final topic at the Mount Druitt STEM Club. So let's get going. So we're going to cover the weather and climate with microbit. And we've got two sessions. We'll do some simple projects this week. And next week, we'll do a couple of projects and look at the more advanced topics. What are we going to learn? We're going to monitor the environment. And in particular, we're going to look at measuring the temperature, that's the air temperature, humidity, and pressure. And we're going to compare the accuracy of different sensors, especially with regard to temperature. And we'll make a temperature-controlled fan, and we'll look at data logging the parameters that we collect on measurements and put them on the internet, and we'll see what the role is of the citizen scientists, especially with climate change. Okay, so the basics parameters we're working with are temperature, humidity, and pressure. But we can also work with wind speed and direction, ultraviolet radiation, carbon dioxide monitoring, and air quality, soil moisture and temperature. And with water, we can look at water quality, the turbidity. And so these are just some of the additional parameters that we could work with. And next week, we'll have a look at some of the extra ones. Okay, so what's different is that we'll start using many sensors at once. So in the past, we might have used one sensor or one push button. So today, we're actually going to use quite a number. And we'll look at the concept of microclimates. And the optional item is that we'll look at logging. And one way to do the logging is to use a micro SD card. Alternatively, we could log on to the internet or use one of the internet websites like ThingSpeak. Or alternatively, we could integrate our weather station into a home automation system using a communication system called MQTT. So why do we measure the weather? Well, it has an important role in agriculture and in farming. We want to aim for optimal levels and not waste water. So we need to know when it's going to rain. We need to know when the climate is changing, and they are important factors for the farmer. We also need to know if we can get some early warnings about environmental hazards, such as the recent rainfalls that we've had, the excessive rainfalls in New South Wales and Queensland. And this is going to continue. With climate change, we're going to experience more and more severe weather conditions, and we need warnings about these. And this can also help in minimizing disruptions in transport and also improve safety. And I'll talk a little bit about that later on. And we can use the results of our measurements as part of a worldwide effort to understand more about climate change and to what extent that it's happening. And we can also monitor our environment to minimize the use of the energy we use. Well, while we've got appliances on all the time, like an air conditioner and nobody's in the room, perhaps we could monitor the number of people in the room and only switch on devices like that when people are around and when they need them. So with climate change, once we know and understand what's happening by collecting more data about our environment, we can do some data analysis and look for the trends, and then we can take some action and minimize the need for using excessive energy. And in my work, I've used weather stations on the road, and this has helped with road safety. And a couple of projects are the M1 driver aid scheme, which was a $10 million project when I was working with the Roads and Maritime Services. And the idea here was that we could detect the road conditions, the weather, and warn drivers in wet weather that their speed was too high, and we advised them to reduce their speed. Also, there are a couple of spots in New South Wales in winter where black ice occurs. And this looks like bitumen, but really it's a dangerous, slippery surface, and it's very easy to aquaplane and cause an accident with cars. And I also use technology to warn drivers about floods. So one of the most dangerous conditions is during the rain, and when drivers are not concentrating, they can easily get into accidents. And a technology like this can help save lives on the road. So besides the computer, we'll be talking about communications technologies. We've already used the USB, but next week we'll talk about the Internet of Things, IoT, data logging, and I'll describe a project where I use 2 microbits. One is inside, collecting the temperature, humidity, and pressure, and the other is outside, which collects those parameters, but also collects the information about the wind, speed and direction, and the rainfall. And I'm going to add these to a global collection of weather stations, and we can have a look at some of these on the internet, and we'll do that next week. So in the data analysis, we can look at the data and look for trends and begin to show that data on graphs, and also plot the data onto weather maps. And the tool that I'll be using for doing this is Microsoft Excel, which is a spreadsheet. So for the simple projects we'll do this week, we'll be using the BME 280 weather chip. And we'll be using extensions to support that on the Microsoft Makecode. And one of the advanced topics I'll just mention this week is how to log the data that we collect to Microsoft Excel. Another project we'll do this week is comparing temperature sensors. And in particular, we'll look at the difference in temperature between the BME 280 and the temperature, which can be sensed by microbit's own internal onboard temperature sensor. For the advanced projects and for next week, we'll look at a temperature controlled fan, weather stations, an Internet of Things weather station. We'll also look at soil measurement and how to send lots of data to Microsoft Excel and look for trends in the data. Okay, so our first project, we'll be using the external temperature sensors. And we'll learn a bit about the BME 280, and we'll display the temperature, pressure, and humidity. And we'll select one of those using microbit's buttons. So we've got button A, button B, and if we press the combination, that will allow us to select the parameter that we're interested in. And when we select that, we'll show the results on a 4-digit LED display. And we'll also look at you programming the microbit so it knows when you are too hot or too cold. And if it is too hot or cold, we'll show an unhappy face on microbit's LED array. And finally, we'll get the results that we've collected and we'll send them off to Microsoft Excel to analyze and display on graphs. Okay, so here's the icons that we can show, and we will show those on the microbit LED array. Now, on these projects, we're beginning to use a bit more power. So don't forget to switch on power to BitMaker, and you need to turn on the power here, and you may have to provide extra USB connection to your computer to make sure that there's enough power to BitMaker. Now, this will be more important next week when we begin to use the motor and the motor control for our thermostat or temperature controlled fan. Okay, so the way we do that, we can connect our second USB cable to microbit that's got a USB socket. And we've now got 2 cables. So for our first project, we need microbit and we need BitMaker. And we're going to connect the Grove 4-digit display to port 0. And to the I to C port, which is on the other side, we connect the BME 280. And you need to connect both of these devices to BitMaker using the Grove colored cable. So the objective for our first project is to learn how to use the BME 280 weather chip, display the results on the 4-digit display, and show how you react on the microbit LED array. And we're going to learn about coding in modules. We'll break up our program into smaller components, and that'll make it easier to understand and program. And these modules are called functions. And we'll also access the BME 280 and the 4-digit display using Makecode Extensions. So here's our first program. And what we'll do is we'll just navigate through that to see how it works. But you can see that it's been broken up into modules with the on start and forever. But we've also got 2 functions, and we've got some actions with our push buttons. So generally, our push buttons are going to select the parameter we want to display on the 4-digit display. And the 2 functions, the get parameters function gets the temperature, humidity, and pressure. And in checking the temperature, we find out whether it's inside or outside the comfort level. So the comfort level will start at a maximum cold of 15 degrees and a minimum hot of 30 degrees Celsius. Okay, let's have a look at the program in detail. So the first thing you need to do is to go to the Makecode Extensions and type in BME, and on the extreme left, a BME 280 set of modules is there. So select that, and it will be added to your toolbox. So you've got a few more statements you can play with. And the first one we'll be using will be setting the address. Now, this is already set for you. There's a default of 0x76. So that's the address. And that 76 is not it's not a decimal number. It's a hexadecimal number. And a decimal number goes from 0 to 9 and then goes on to the next column, which is the tens column. Here, we don't go from 0 to 9, we go from 0 to 16. So when we go beyond 9, we begin to use the first letters of the alphabet from A to F. So this is easier for a computer to understand, but perhaps a little bit more difficult for us. So it's a hexadecimal address. And the other module that we start with is that we turn on the power. So these are the two modules that we need to work with. And we're going to select the temperature, humidity, and pressure. So on startup, we're going to name our program W2. And we set the address. It's already been set, so that default address is the one that we need. So don't change the address. Select the power on module, and we're going to set up two variables. One is the temperature cold and the temperature hot. So anything below 15 degrees, we're going to show an ugly face on our microbit LED array. And anything above 30 degrees, we do the same. And in between those temperature range, we feel quite comfortable and we'll show a happy face. But we're just setting up the parameters at the moment. We also go to our Grove toolkit and select the 4-digit display, and we connect the 4-digit display module to port 0 on the BitMaker board, interface board, and that will go into port 0 and port 1 on our microbit. So make sure that you select both port 0 and port 1 in the way that I've indicated. Next, we'll clear the display and we'll just pause for 1 second. The next module, we're going to create two functions. One is get parameters, and we'll also call check temperature. Then we'll pause for 2 seconds. So those functions, let's have a look at those. We're going to set my temperature, my humidity, and my pressure, the ones that we created for the startup. We're going to use the temperatures that the BME is able to measure. And the ones in blue, the blue temperature, the blue humidity, and blue pressure are mapped on to our variables. So we need to create those 3 variables on the left and then link them to the climate parameters on the BME 280. And the other function, which is check temperature, we then just check to see if my temperature is less than the cold threshold. And if it is, we show an ugly face. And we check my temperature against the minimum hot temperature. And if it is hotter than that, we also show an ugly face. Otherwise, it's in between and we show a happy face. Okay, so with our buttons, we use button A to select the temperature, and we'll show T on our microbit LED array. So we're using two displays here, both the microbit LED array and also the 4-digit LED display. And with button B, we do something similar, but we use humidity this time. And for pressure, we select the pressure measurement with the combination of pressing buttons A and B together. Okay, so if you go ahead and create that program, then download it and tell me how it works. Now, as an extension to this project, we will send the results not just to the 4-digit LED, but we'll send them to Microsoft Excel and plot them something like this. So we can have a graph which on the horizontal axis can show time in seconds, and on the vertical axis we can show the temperature in degrees C. And you can see the trends, and this might give you an indication of how it might go in the future. So there's only just a couple of simple changes to make to your previous program. So keep your previous program and we'll add those. And what we're going to do is get an array of temperature, humidity, and pressure and send it on the microbit's serial communications port, which is just the USB port. And you would have had the microbit already connected to your PC. And when you use that block of instructions, it will send the parameters to your Windows PC. Okay, so that's the main block that we have to add. But in order to do it, we need to, I'm going to use the logo, and this is the first time that we've used the logo touch button on your microbit. And when you press this, we set a flag, and it's going to be called the log flag. So it just toggles. So each time you press the log flag, it turns it to true or false. It just toggles between the two of them. And depending on that flag, it will then send in the check temperature function the functions on the serial port. Let's have a look at the program in detail. It's almost identical to the previous program, so we'll just concentrate on the changes. So to change the what we now do is we're going to add the logo function, and we enable it right at the beginning. We set a new variable. So you need to create a new variable called log flag, and we'll set that to false on startup. So that's the only additional command or statement that you add to the on start block. And the other block that we add is we select from the microbit toolkit, from the inputs, select the logo, and that's right near the bottom under microbit version 2. And we just add some logic statements with an if and an else. And the final one is that we log that to Excel. So on the previous check temperature, the last block is going to be the serial write block. And you'll find that under the toolkit, under advanced. So select the toolkit, and we're going to send an array of temperature, humidity, and pressure. And it will also, besides sending the variables, it will add a comma in between. And by doing that, that makes the format compatible with Microsoft Excel. Okay, so the results, we should have not only displayed on our 4-digit LED, but we've also displayed on Microbit's LED array, whether we're happy or sad. And we've this time added routing the results to the serial port for our PC to pick up. And our PC should get the results like this. So on communications port 8 here, and your computer will use a different comms number. to connect the microbit to the Windows PC. So the first one is 23 there, is the temperature of 23, followed by a humidity of 62, and that's followed by the pressure in pascals. Now, the pressure in pascals there, on our 4-digit LED, you notice here that the precision is a lot more. And on our 4-digit, we wouldn't fit that number in. So we select hectopascals on our 4-digit LED display, and it will come up with 1009 and not 100921. And we can graph those results. So I'm using a program to test all this out called the Arduino IDE. And this is what it looks like. The pressure maintains a similar pressure. Now, what I've done here is to further divide the pressure by 10. So everything fits comfortably on the one graph. And you can see the trend in humidity. So as I'm breathing in and out, there's more water vapor being added, and it's corresponding to the changes in the graph. Whereas the temperature has remained much the same, just under perhaps about 27 degrees. Okay, so in our next project, we're going to compare temperature sensors, and we're going to look at how the BME compares with the microbit. And we could also compare it with other temperature sensors. And the one that I've chosen here is the DHT, but that's for a more advanced project to include that in the comparison. So the objective that we'll do is to compare two different temperature sensors. So the first one is the microbit temperature only, and the second one is the BME 280, where we just continue measuring the parameters as we did before. But this time we'll actually compare the two temperature readings. So for our hardware, we use the same devices that we had before, so there's no change. And don't forget to switch on power to BitMaker, and that's our hardware. So for our software, it's very similar to the previous project, where we'll use the log flag this time, and the onlog logo, we'll use that for a different purpose. So that's the only change. So we won't be logging to the serial port, but we will select now. If you press button A, we'll select temperature from the BME 280, select humidity by pressing button B. By pressing button A plus B, we select pressure. And this time, if you press the logo button, we will show the microbit temperature on the 4-digit LED. Everything else is very similar to what we had before. And you'll notice that we're selecting hectopascals for our pressure. So the only change really is to use the logo button. And you get that by going to the microbit Makecode toolbox, and for version 2, select on logo. So when you press that logo, the first thing we do is clear the screen. And the second thing we do is we pause for 2 minutes. Then we set up a link between the microbit temperature, and you can get that microbit temperature from the same group of statements in the Makecode toolbox, and just drag that across and connect it to a new variable that you need to set up in the on start. So our new variable is called microbit temperature. And once we connect the two of them. We then show the microbit temperature on the 4-digit LED display. And the results, we'll be able to compare, and it'd be interesting to tell me how those results go. Are they the same or are they different? And if they are different, why could that be? Okay, and we could take it further and take all the parameters and put them to Microsoft Excel and compare the differences there. Okay, so that's all for this week. And for next week, we're going to have a look at a thermostat using the same hardware, but adding to it a Grove rotary angle device or a potentiometer, and we're going to use that to set the control temperature to turn on a fan. So previously we had an upper limit of 30 degrees. Now this time we're going to adjust it, and we adjust it with the potentiometer. And the fan will go on if it reaches the threshold temperature, and that'll keep us cool. And we'll do that project next week. So that's all for now, and see you next week.